Hey, good afternoon. Just want to welcome everybody to our webinar this afternoon titled Sprint or Marathon, Go the Distance with the Data Center. Just a quick little background about Service Express. We're a leader in data center maintenance. We've been helping IT professionals be more successful by meeting their needs with solutions that fit. So today, your hosts for this are going to be myself, Chad Peters, and Jake Blau. One thing about Jake and myself is we're really from the technical side of our business. So we're not in the sales team. We're really here to educate you and share some insights with you over this next 30 minutes. I've been with Service Express for over 20 years, focused on the technical side and education. Jake, why don't you tell them a little bit about yourself?
Yeah, good afternoon. Yeah, I'm Jake Blau. I'm the Chief Technology Officer for Service Express. So I've been in the hardware realm at Service Express for about 19 years. And I work with the product support division of what we service and also our data science teams.
Fantastic. Thanks, Jake. So our goal today is, we think about the data center. We're going to put this in terms of a marathon. Both Jake and myself, we claim to be long distance runners. We try our best. So we're going to make today about running a marathon. And when we think about putting those terms in the data center, we're going to focus on what matters for you in the data center. We're going to talk about some mix and match opportunities when it comes to service. And that's really going to lead us to the end where you're going to be able to walk out with some strategic best practices. So as I mentioned, we want to start by laying out the course. So when we think about the data center, and Jake and I have had the opportunity to be in front of a lot of IT managers, chief information officers, data center managers. And what we hear often is we've got to navigate this course. There's typically a handful of things that come up throughout the days and weeks and months in the data center. One of them is uptime. That's critical. How do I maximize the uptime of all my equipment in my data center for all of my users? A big part of that is security. How do I make sure that all of our data is secure? Everything is up to speed and working like it's supposed to be with optimizing those operations. And last but not least, I've got to have dollars to pay for it. I've got to have funds set aside. I've got to have the right budget there. So what Jake and I are going to do today is really talk about answering and diving into these four realities of navigating this course. Another thing we're going to talk about as we get into this is refresh cycles. What does that look like for most data centers, and what could it look like? We're going to share some examples and scenarios of different options for you for those refresh cycles. And along with that, we know a big part of managing the data center is really maintenance. How do I keep things running and finding the right provider, whether that's the OEM or a different option? And we think about OEM maintenance. I mean, we've all realized this over time. It's certainly expensive to have that maintenance. It may not be as flexible as you'd like. And, potentially you may have experienced a little bit of a decline in service levels over the years. So Jake is going to take us through and really start with kind of the timeline for equipment and its life cycle.
So when we think about our data center and thinking about systems and storage and networking, and we know that there's a lot of other variables in this, software, virtualization, applications, a lot of things that tie into why you would keep or why you would decommission a piece of equipment, why you would refresh things. We're just going to talk through some hypotheticals on what we see some of our best case customers doing that's saving them a lot of dollars. As we think about our equipment, we always have that first 0 to 3 years. That first 3 years, the OEM sells you a box. It's under warranty for that 3 years. They typically include some level of on-site maintenance with that purchase. And then after that third year, they're probably knocking on your door to say, yep, it's been 3 years, it's time to buy a new widget. And the reality is that there's a lot of life left in that machine. And for that 3 to 6 year period, you have a lot of options for maintenance. The OEM is going to provide maintenance. Third parties are going to provide maintenance. And even past that, as we get to 6 to 9 years, the manufacturer will still maintain some items based on what their sparing looks like, based on what failures look like, or what they say it looks like. And then you have ongoing post-warranty coverage. And then many of our customers are actually still using machines in that 9 to 12 year period using just a third-party maintenance. Typically, somewhere between that 6 and 9 years, the manufacturer says, yep, that's not something we're going to maintain anymore. You need to decommission it. You need to replace it. Regardless if that's doing a good job for you or not in the data center, they usually say it's time to buy new. So as we move forward, what managers assume that most companies do, and as we talk to a lot of these different IT professionals, everybody kind of thinks what everybody else is doing is a lot faster and shinier what they're doing. So what managers assume that companies do is that every 3 years, they're installing, running, refreshing, recycling, and rebuying hardware. Now, what most companies actually do is that cycle in 6 years. Typically, a company is keeping their assets at least 6 years, 3 years with that warranty, and then additional 3 years with a post-warranty maintenance. What we're suggesting that what companies should do is just extend that a bit more. And on average, keep your equipment at least 7 years, and depending on the application, possibly even farther. So we're going to ask a quick poll to the audience out there. How long are you typically keeping your server, storage, and networking equipment? All right, interesting. So we had about 50% of the audience say 3 to 5 years, and 50% say 6 to 7 years. That is encouraging.
So now we've had a chance to talk a little bit about kind of life cycle of product, that there are options out there. We got to see just kind of where all of us are at today. One of the things we want to talk about is, let's say you are going to hang on to that product, right? You're going to extend the life of that product beyond warranty. What are some of the things that are going to pop up that you're going to have to navigate in your data center? One of them is going to be disruption. Another one certainly is going to be budget. And then we're going to talk about some timing and also managing risks. So when you think about hanging on to that hardware a little bit longer, what risks might appear for hanging on to it longer, or what are some of the perceived risks that we think are out there? So I want to start with and really talk about disruption. So when I think about disruption, or I'm going to use the term disruption this afternoon, I'm going to focus on updates, right? We all believe that we've got to keep all of our products up to the latest and greatest firmware and code to minimize any unexpected downtime. And so that also leads us into some of those refresh cycles. When we think about firmware and microcode, as it might be called, depending on which manufacturer you're working with, a lot of times in that first year to 3 years, that's when you're seeing the heaviest code volume, potentially even monthly. It's a new product out on the market. The bugs are being worked out. There's been enhancements to it. And then what happens is, as you get to that 3 to 6 years, so the warranty has expired, you're now into that post-warranty time frame. Now you're going to see code traditionally decrease. Now, don't get me wrong. There will still be code updates that can come out as you get into 3 to 6 years and potentially even beyond. But the vast majority of code now has decreased from what it was. Those first 3 years, we're putting code out there to enable new features, new enhancements. But as we kind of get beyond that, and now they get to a stable state and they've hit that somewhat end-of-life product, now we're getting into code comes out maybe now to correct problems, right? Maybe some bugs that might appear as the product has been out running for a while.
And to add to that, there's in the 11 code updates that we typically see in the beginning, those are generally the very critical things. They've released a box and they have found that there's a back door to the remote insight. They have found that there's a crash that happens with certain processors. In the later code releases, you typically see, oh, here's a release of code to support a V4 versus a V3 processor, or to support a new I/O card, which is less critical for people at that point. And you can also time your purchases to do your purchases towards the end of that run. And Chad will talk a little bit more about this later, but they generally manufacture one of these servers for 2 to 3 years. And if you can time your refreshes to buy the last one off of the production line versus the first one, not only do you get more performance per dollar, but you can also pick it up at the end of the code run so that you're not beta testing for the manufacturer.
Along with that, when we think about code that's out there, sometimes you get security code, and really in many, many cases, the OEM is going to release that code regardless of policies, because again, it's talking about safety and security. So in those cases, those updates will be made available regardless. So I did mention as we kind of go along a timeline and get more years on that product, this is roughly what your life cycle of firmware looks like. That first year, you start heavy, right? Maybe monthly, maybe quarterly. You're doing codes are coming out again to fix problems as that product is brand new. And as Jake mentioned, as that life cycle continues, now we kind of get into we're releasing code so that you can support a new hard drive, a new processor, a new PCI card, PCIe card, whatever that might be. So as our customers might hit, and as you might hit, that stable state where this thing just works for us, like it's doing what we need to do, it's running our business the way we want it to run, you realize that, you know what, maybe having access to code through the OEM isn't as critical as it was in years 1, 2, and 3. Now that I'm in year 5, you know what, we're really not applying updates because we don't want to do a disruption to our data, right? We don't want to shut the thing down and have to reboot it during the day. To put a code bug on or put a code fix on, that doesn't really apply to our current environment. So this is typically what we've seen. It really ties back to what Jake talked about with life cycle of hardware. As we kind of get to that 6 years and beyond, right? What a great opportunity to look at other potential avenues to continue the life of that product. So Jake, why don't you take us through talking about dollars and budget?
And as we mentioned before, there's a lot more to the IT budget than just the hardware. The hardware may even be a smaller part than your software, your licenses, your virtualization, your applications, et cetera. But we're going to kind of walk through a little bit of a case study of what it really means when you can extend the life cycle of your hardware. And so if we look at a typical 3-year refresh cycle, and use an example that we have a 60-member PowerEdge cluster, and we refresh 1/3 of this annually. Our customers that do refreshes really well refresh a certain percentage of their compute and a certain percentage of their storage and a certain percentage of their network annually, instead of doing a rip and replace of all storage or all systems, going back to that disruption that Chad talked about. So if you look at a 1/3 of a refresh, you could spend $900,000 over 6 years. If you have all new machines that you're refreshing on a 3-year, your 6-year cost is $900,000. Now, if we were to do things a little bit differently and say we have a 6-year refresh cycle, so we're refreshing 1/6 of that annually, now we're only going to spend $720,000 if we go with the status quo, meaning we're just going to have the OEM do everything. Putting a third party into the mix, you can reduce your expense quite a bit more. You're going to save, going from a 3-year refresh to a 6-year refresh, you're going to have a savings of $180,000 to $330,000 over 6 years. I didn't do the math for 7 years, but essentially for every year, for every 1/7 or 1/8 that you refresh, you can pay for your refreshes without increasing your budget.
So as Jake talked about refreshing and timing and extending the life of a product, you're going to see, and we're going to show this in a second, you're going to see that really technology comes out and it kind of plateaus and then it spikes, right? You get something new and then it'll plateau for a while with small upticks, and then you'll see another spike as new evolutions come out. So one of the things that we're going to talk about here is really you can purchase more power with the next generation of equipment just by holding back a little bit, right? Just kind of waiting another year. So kind of ride that plateau out and then catch it right before the spike again and go on to the next plateau. You can kind of see that here as we take a look at processor performance over the years. You'll see, like even in the Intel Xeon group, you'll see that it kind of runs a little flat, you know, in 2008 timeframe, 7 and 8, 9, and then you'll see it go up, and then it kind of plateaus, and then it spikes again. So this is a great thing to start to look at in the data center is, if I'm going to extend the life of the product, how can I ride that out so that I'm catching the next wave, right? That I'm bringing in that next hardware at the right time and catching the next generation of processor enhancements and then I keep it, run that plateau, take advantage of other options in the data center, free up some of that capital expense, and then refresh again and catch the next cycle of uptick in performance. So that kind of goes into, being able to extend that life cycle of product.
So then the last bit of it, and this is really one of the most important things, is no one likes downtime. Users don't like not being able to log into the system. And so one of the biggest things we hear about is, 5 nines uptime, and we can't have downtime, and all of that. And so we've been doing some studying, and Service Express has 25 years of maintaining computer systems and storage systems and network devices, and we have a ton of data. We've had over 1 million devices under maintenance in that 25 years, and we track everything. And one of the things that we track is how often do things fail. And as essentially the claims department for the insurance company, we know that if your hardware breaks, we have to come out and fix it. We want to make sure that we're putting things under agreement that are reliable. And so we always study all of the different servers, what's reliable, what's not reliable, what do we want to service, et cetera. And we had some really interesting findings coming out of this that we've now turned into like a couple of small slides as an example, but that we'll talk you through, that all of the different hardware platforms exhibit almost the same amount of reliability, and that they exhibit also the same amount of reliability over time. So we're taking a look at this UCS product family. We're speaking to the generally Cisco UCS Blade servers, and we took a look at all of the Blade servers that we have under maintenance for all the months that we've had them under maintenance. And we said, okay, how many of those blades actually fail on a monthly basis? And when they fail, how do they fail? So we took a look at all of the failures and what was the part that actually failed on that device, and did that part failure cause downtime, meaning critical, meaning it no longer functioned, or was it a non-critical error, like a hard drive, a memory DIMM, where the machine was still operating but wasn't down? And what we found was really interesting. Looking at the bottom, those are the number of months. So under an average tenure of 51 months for a UCS Blade, so going up on about 5 years, the amount of failures that were critical on UCS Blades was almost 0%. It was 0.001, meaning that for every 1,000 blades, one of them would fail on a given month. And then at that 0.14% of a non-critical failure, where we just had to do something concurrently, slightly higher, but 0.14% of UCS blades had a failure in any given month. And that over the course of that 5 years, the failures actually decreased, not increased. And we thought, well, that's super weird. Let's take a look at another product family, because that can't possibly be right. And so we looked at HP ProLiants. And we had over 330,000 ProLiants under maintenance under some given time. And so we took a look at those, and month 1 out to month 146, which, if I'm doing the rough math correctly, is 11 to 12 years, we saw the same trend. While critical failures were higher than in the Cisco UCS Blade, there was still only a 0.1% chance of any given ProLiant failing on any given month from month 1 all the way to month 146. Now, the non-critical rate did go up very slightly, 0.8% to 1%. So for every 100 systems, one of them had a failure on any given month. So with the way that typically the failure curve is explained to people from the manufacturer and from other sources is it looks kind of like a smiley face. What we call the common knowledge is when they come out and they're brand new, they break a lot because they're brand new, and then they settle in and they don't fail, and then they get old and then failures skyrocket again. What we found is that actually is not true. In 20 years of our data and millions of machines, it's not true. Typically, they don't fail any more when they're brand new than they do when they're a decade old, which was really shocking to us. And we thought, hey, let's go look at a couple other examples. we did the same thing for Power Edge. And while the Power Edge was a tiny fraction more reliable than the HP, it still had the exact same failure characteristics, a 0.1% for a critical and a 0.8% for a non-critical, with a tiny decrease over time. And then we thought, well, hey, let's look at something a little bit bigger. So we looked at IBM Power Systems. Now here we actually saw a big difference. Now that critical failure rate was still essentially 0%. But we did find that the non-critical failure rate, which was basically hard drives, did go up over time. In studying that, we actually found that in Power Systems, there's a cache battery that has to be replaced over a certain amount of time. We found that we replaced about 700 of those last year. And then we also found that most of these Power Systems have 30 to 40 to 50 hard drives and expansions tied to them. And that's what gave them that higher failure rate. But even expanding on that, we're talking 12 years into the tenure of a power system, there's a 5% chance of losing a hard drive one in any given month. Now, this would lead to tell you, well, if the failure rate is so low, then why would you even need maintenance at all? There's the obvious question. Now, I will also say that my house has a 100-year record of not burning down, but I still have home insurance. Because when something does go wrong, I don't necessarily want to have to fix it myself, nor do I want to necessarily have all of the parts on hand to say this is what my house is going to have a problem with. So what I kind of want to leave you guys thinking about is the pricing strategy from the manufacturer for maintenance. If you do some of the math, roughly your maintenance bill for post-warranty for 3 years is typically about the same amount as to go buy new stuff. That is not by accident. That is intentional because they want you to refresh. They are a hardware sales company, not a maintenance, not a service company. So what we would say is, you guys know that this stuff doesn't break that much. You know that every day you're not having critical faults in your data centers. So there's a lot of room to be saved, not paying the list price from the manufacturer, but going to a more affordable option. And we use all of this data in our pricing structure. We know the failures, we know what fails, we know how much it costs when it does fail, and our pricing is a reflection of that. So people will say, well, how is a third party so much less expensive? We're less expensive because we know that things don't fail as much as people think. We know how much it costs when it does fail. We can price appropriately to run a business, but also give you significant cost savings.
So as we kind of wrap up that section on those 4 areas in that data center, navigating that course, kind of running our marathon through data center maintenance, that's a story that we wanted to be able to kind of share with everyone on the call today. Is, we think about extending the life of that product longer than that 3 to 5 year refresh. We had some risk there, right? We had, well, what happens with firmware? Is that going to continue to be a risk for me? But we saw the frequency of firmware updates decrease drastically. You said, okay, well, what about dollars, right? I mean, how costly is it going to be to extend the life of this product? Jake walked us through what budget could look like by doing so. And we also talked about technology, that I can ride that plateau out a little while longer and be able to still keep technology in my data center that allows me to run at the rate that I need to. And then lastly, a big concern, if I'm going to extend the life of my product out there, well, it's got to break more. I mean, it has to break more. And as Jake walked through a lot of the data that we've been able to gather, we've seen that this isn't the case. So those are kind of debunking those 4 myths that are out there when you think about extending the life of your product. Why do it versus why not do it? So let's say that you've got to the end of this webinar, and maybe you've already been kicking this idea around a little bit, that you're thinking, well, I want to explore going with a third-party provider. I want to look outside of the OEM. I want to do that. What do I have to do? Like, what should I do first? And the first thing that we would suggest is come up with a checklist. Ask the tough questions, get answers to them. And so this is just a rough checklist that we put together with some common items your business might be wired a little differently. But the first thing I'd suggest is really sit down and put together a checklist, have conversations with different providers, and see how they respond to your checklist. Again, you can rip off and duplicate this one, that's fine, and use that as a launching pad and add more to it or take a few things away from it. But really do that research and do that due diligence and look at those different opportunities that are out there. And so we'd like to open it up in the time that we have remaining just to answer any questions that you might have. Again, there's a question thing up, a pod up there that you can ask questions. If we don't quite get to them today, we can certainly respond to you after the webinar as well. So we'll just give a second for any questions that might be out there.
And we'll also offer, so the failure analysis graphs that you saw up above, we've actually done these for multiple companies who are wondering about their particular infrastructure. And for many models, we can get right down to the model and say a DL380G5 looks like this, a DL380G6 looks like this. So if you would like us to look at your infrastructure and do a failure analysis, we'd be glad to do that. You can contact the email below and they'll send you over to myself and the data science team. We actually ran a large cosmetics manufacturer through one of these yesterday, and they're struggling with budgets, they're struggling with refreshes, and we gave them the information that essentially the particular equipment they had, most of it was good for over 10 years, but we were able to point out 3 individual model numbers that showed abnormally high failure rates that we suggested for them to refresh for reliability reasons. So if you'd like to engage with us on that, we would be glad to talk to you about that. And obviously, if you would like to get a quote or to talk more about third-party maintenance, the email and the phone number is right there on the screen.
Fantastic. Thanks, Jake. And as we wrap up, what you're going to see pop up, you're going to be prompted for a survey. So again, your feedback is critical. Our goal is to continue to provide education to our customers out there. So please take a few minutes and fill out that survey. Again, we want to keep offering these solutions up and make sure they are impactful to you and your business. So take a few minutes and fill that out, and we look forward to seeing those come in. Thanks, and have a great day.